Right, I'm back with another video. Today I'm going to show you my data collection of a whole bunch of elastic collisions that I've done once again with my toy cards. Yes, with my stupid little toy cards, which happen to conserve momentum quite perfectly, as I'm about to show you. So I have done about 120 tests. And the first 20 tests are with this card and this card. So I let this card collide into this card. This one has a mass of 0.32 kilograms. This one has a mass of 0.65 kilograms over here, which is a little bit more than twice the mass. So 20 tests, I let them go through the photo gates, and then I insert the timings into Excel, and Excel has calculated all the velocities and the momentums and the kinetic energies. So let's take a look at it. We have 20 tests here. This column here shows you the momentum before collision. So 0.15 is the initial momentum before collision. Then after collision, card 2 comes out with 0.19, and card 1 reflects back with 0.02. So now let's check. All right, in order to check conservation of momentum, for conventional science, we have to subtract the card going back, the momentum of the cards reflecting back, because direction matters. And then I also have a column here. So this is a vector column. When we treat momentum as a vector, so this is for conventional science. This column here is when we treat momentum as a scalar. So this is the way that draft science would treat momentum as both positives. And so as you see, first, let's check out conventional science. So this is the initial momentum. This is when we treat it as a vector. So we have 0.15 versus 0.16, quite close. 0.17 versus 0.17, 0.16, 0.16, 0.20, 0.20, 0.17, 0.17, 0.14, 0.15, 12, 13, 13, 13, 14, 14, 18, 18, 17, 17, 18, 18, 15, 15, 14, 14, 12, 12, 15, 15, 11, 11, 13, 13, 17, 17, 20, 20. As you can see, momentum is conserved perfectly, very well. Okay, this is when we treat it as a vector. Coincidentally, each time when we subtract the momentum going in the opposite direction, we get the initial momentum before collision perfectly. Each time, 20 runs. Only in the first couple of runs, yeah, it's 15, 16, it's one off, 17, 17, same, 16, 16, 20, 20, 17, 17, 14, 15, one off, 12, 13, one off. That's like the maximum error. That's the maximum difference. Now for draft science case, he would add them together. So we have 15, and when we add them together, 22, 15 versus 22. Oh yeah, free momentum. 17 versus 25. Oh, free momentum. 16, 24, free momentum. 20, 20, 20, 31, free momentum. 17 versus 26, free momentum. 14, 21, 12, 17, 13, 19, 14, 20, 18, 28, 17, 26, 18, 29, 15, 23, 14, 20, 12, 18, 15, 23, 11, 15, 13, 19, 17, 26, 20, 29. Literally each time we have free momentum. So 20 different trials, free momentum. Each of one of them is a free momentum experiment. Oh, I must have engineered it. I must have faked this one. Oh no, but it's stored in the wheels, right? It's the rotational, the extra momentum is stored in the rotational momentum of the wheels. Oh yeah, well, how much extra energy stored in the wheels? How much extra momentum? Oh yeah, precisely, coincidentally, the amount of momentum that reflects back, right? No, it's not stored in the momentum, it's the momentum of the card one reflecting back. All right, then the next trial, the next 20 trials is with card 2. So instead, let me enlarge this. So first I've done this card colliding into this card, and then I've used this one, a different card. Then I did 20 tests with these ones, right? So let's check it out. So we have mass one is still the same, 0.32 kilograms, and then the other one is 0.53. So less than twice the mass. So this is the column of the initial momentum, and this is when we treat it as a vector. Is momentum conserved according to conventional science or according to draft science? So first, let's check out conventional science. 0.19 versus 0.189. Very close. 0.20 versus 0.20. 0.19 versus 0.18. 17, 16, 22, 21, 19, 17. I lost a little bit. 19, 18, 19, 18, 22, 21, 19, 19, 23, 23, 26, 26, 18, 17, 9, 19, 18, 17, 16, 18, 17, 17, 16, 21, 21, 17, 16, 19, 18. All right, so 20 trials, and in this case, mostly we had one of. A very small difference, okay? Now, when we treat it as a scalar, so in draft science case, what would we have? 19 versus 25, 20 versus 26, 19, 25, 17, 21, 22, 30, 19, for 24, 19, 24, 19, 25, 22, 29, 19, 27, 23, 32, 26, 37, 18, 22, 19, 25, 17, 21, 18, 24, 17, 22, 21, 28, 17, 21, 19, 25. Once again, literally each time more momentum than the initial momentum. Free, and once again, so with a different car, it's another free momentum experiment. 20 different trials, 20 free momentum experiments. You faked it. It's engineered. Oh no, but it's the extra energy stored in the rotation momentum of the wheels. How much extra energy? Oh yeah, precisely the amount of momentum, all right, that reflects for cart in cart one reflecting back. Next series of 20 trials. Cart 3, I have used another cart. So first it was this one versus this one. Then it was this one versus this one. Then it was this one versus this one. I have another cart, the third cart. All right. Let's see. So this one has a mass of 0.64. So this one is precisely twice the mass, precisely twice the mass. Doesn't really matter what masses are, momentum is always conserved. So this is the column of the initial momentum, 15, and then when we treat it as a vector, 0.15 versus 0.14. One of. 0.17 versus 0.15, two of. 0.13, 0.12, 0.17, 0.59, 0.16, 0.15, 0.15, 0.13, 0.14, 0.13, 0.15, 13, 18, 17, 17, 16, 13, 12, 15, 13, 16, 15, 18, 17, 17, 16, 15, 15, 14, 15, 14, 17, 16, 13, 12, 15, 14. Each time we have a little bit off, but there is a reason. There is a reason, okay? I have first done it like this, so you can see the added mass is on this side. I couldn't place it in the center. I first done it like this, and then I've switched it around, and then I got perfect results. So I don't know whether it was like this or this, but in one case, we've lost a little bit of momentum, which is in this case. Each time we lost a little bit of momentum, and then in the next one, I've turned it around, right? Which is over here. I've turned it around, and then we got perfect results, which is over here. So this is still the same card, but just turned around. So in this case, we have 0.16 versus 0.16, 13, 13, 13, 12, 17, 17, 21, 21, 14, 14, 14, 14, 15, 15, 17, 17, 13, 12, 18, 18, 17, 17, 16, 16, 12, 21, 22. Uh-oh, free momentum. 17, 16, 23, 24, 21, 21, 18, 18, 17, 17, 15, 15. So in most cases, the momentum are perfectly conserved. The momenta. And for this one, even when put like this or turned around, in both cases, for draft science, still this is free momentum. Let's take a look, 15. So now we compare it with draft science model, 15 versus 21. Oh, extra momentum. 17, 24, extra momentum. 13, 16, 17, 24, 16, 23, 15, 21, 14, 19, 15, 21, 18, 26, etc. It's always more momentum than the initial momentum. All right, and then in the next test, where I turn it around, it's the same story. 16, 23, oh, more momentum. 13 versus 17, more momentum. 13, 17, 17, 25, 21, 31, 14, 19, 14, 20, 15, 21, 17, 25, 13, 17, 18, 26, 17, 24, 16, 23, 21, 30, 17, 23, 23, 34, 21, 30, 18, 26, 17, 25, 15, 22. So once again, literally in each trial, more momentum than the initial momentum before collision. Then in the next test, the next 20 trials, what I've done is I took off this spring and I put another spring on it. So I've used two different springs, and then I let it collide once again with the first card. Okay, so with a different spring now. So let's see, we have the initial momentum, and then when you treat it as a vector, so for conventional science, we have 0.13 versus 0.14, 15 versus 0.16, 15, 15, 16, 16, 17, 18, 14, 14, 18, 19, 16, 16, 14, 14, 16, 16, 17, 17, 15, 15, 14, 14, 14, 15, 14, 14, 15, 16, 19, 20, 14, 15, 18, 19, 18, 18. Once again, in most cases, momentum is perfectly conserved. Sometimes we have one off, only one off. Now for draft science, we have 0.13 versus 0.19, 15, 23, 15 versus 22, free momentum, 16, 23, free momentum, 17, 27, free momentum, 14, 21, 18, 28, 16, 25, etc., 14, 21. It's always the same scenario, 16 versus 24, extra momentum, 17, 25, extra momentum, 15, 22, extra momentum, 14, 20, extra momentum, free momentum, free momentum, free momentum. And then the last 20 trials is, once again, so we have this different spring, colliding against card 2. So we have the different spring colliding against this one, and then we have the different spring colliding against another card. You know what? All right, so this is the final thing, the final 20 trials, initial momentum, 20, when you treat it as a vector, so for conventional science, 0.20 versus 0.19, 0.25 versus 0.25, 0.20 versus 0.20, 20, 20, 18, 19 versus 18, 19 versus 19, 19, 19, 17, 17, 23, 23, 19, 19, 21, 21, 20, 19, 19, 19, 19, 18, 22 versus 22, 20 versus 19, 20 versus 20, 21 versus 21, 19 versus 18, 20 versus 20. So once again, come on, this is getting so ridiculous. It's so obvious now. And each time when we apply conventional science, when we treat the opposite direction as a negative momentum, when we subtract the momentum, we have a perfect results. The mostly 7 out of 10 times the initial momentum is the same momentum when we subtract the momentum after collision. Whereas when we treat them as a positive, we always, literally always end up with free extra momentum. 120 trials. 120. And momentum is only conserved when we subtract the momentum of the going up in opposite direction. Otherwise, when we apply a draft science model, we always gain momentum. We always end up with free extra momentum. So 120 trials, all of them fake, silly, engineered, free energy generators, can be true, must be wrong. Oh, we have to find an explanation. What's the explanation? Oh, there's extra momentum. Where is the extra momentum stored? Oh, this is his new argument. It's stored in the rotational momentum of the wheels. Well, how much extra momentum is stored in the wheels? Well, always in each trial, 120 trials, the extra momentum that we're dealing with is precisely the momentum of card 1 bouncing back. Go ahead and deny 100 new trials. More real physical evidence that proves you wrong. Once again, once again, once again, once again. You are a pathetic evidence denier. Yes, you are.